please help me welcome Dr. Masri.
Yeah, okay, thanks. Thank you very much for having me, the university. Richard, thank you for the kind introduction. I'm very excited to be here today, especially around such an important topic. I want to explain a little bit about how I got here. So it was mentioned that I'm from UCI, University of California, Irvine, and I do air pollution research there, as was mentioned. But over the past 3 years or so, since I've been finished my graduate degree and been working on in science, or at UCI, I've been sort of publishing papers and doing what scientists do, but increasingly watching this issue of climate change sort of race towards what it increasingly looks to be a precipice. And meanwhile, the scientists at the universities are very aware of what's going on and concerned about the science. But then in the public, I was still sensing a lot of confusion and this issue of climate debate you sometimes hear about. Well, I thought, what can I do more other than study science? Because there's already so much great science out there. Do we need me just continuing to work on this type of work, or can I do something more to contribute? So I had this idea of going on the road for climate action, just simply sort of dropping what I was doing at the university for about a year or so, and just going around talking to communities about climate change. Giving presentations like this, although sometimes a room full of 5 or 10 people, and then sometimes 7 or 10 or 20 or 1,200. So communities of all sizes, whoever will welcome me, I will come and inform and talk about climate change, but also hear from communities. I surveyed the public, collected around 1,000 surveys to better understand climate change sentiment and how it varies across the country. Now, what I'm going to talk about today is a little bit about the causes, impacts, and solutions related to climate change. But importantly, there's going to be a little bit of a theme. It's going to be a theme that sort of is in line with this book that I've written. It's called Beyond Debate, Answers to 50 Misconceptions on Climate Change. Now, it's a book that is basically 50 short chapters explaining climate misconceptions in an easy to understand language. It's very in theme with my interest in getting science out to the public rather than just writing science for scientists. So that's what I've written, and I'll talk today about climate change a little bit in the context of misconceptions and try to resolve some of those here today. But also in the context of this national outreach project that we did. When I say we, I'm talking about myself and my fiance, both of us who packed our bags and went on the road. We did a 3-month journey. Let's see if this laser pointer is, can you see this or no? Yeah, some people can? Okay, I actually can't, so I don't know if it's very useful. I'll be pointing into the wrong object. So we went across 36 states over 11 weeks, and that was the first leg of this journey. We spoke to many different communities, and we came back from that project, and well, we both had already sort of foregone work for the year. As a teacher, you can't just come in mid-semester and decide you want to start teaching again. So we thought, let's go back on the road and talk to more communities. Let's go through territory we haven't covered yet. So we went through the Northeast, if you can make it out, the lines here. So we tackled another 7 states over 6 weeks, or 16 cities over 6 weeks. So we've been really busy this year, but we haven't come to Modesto yet, so I'm very excited to be here today. And through this talk, I'll be sharing some of what we observed while we were on the road for climate action. So I'd like to start, as I mentioned, sort of weaving through some of these misconceptions. There's a very widely held misconception that I hear oftentimes, probably the most widely held misconception I've heard, period. And it's that Earth's natural cycles explain recent warming. Now, there is some absolute things that drive the climate that are both natural and man-made. I want to just pause for a moment to talk about some of those natural drivers of the climate. Now, somebody might come up to you and say, well, climate change is natural. It's always happened. And if you're very passionate about climate change and climate action, your tendency might be to say, no, climate change is not natural. It's all human caused. You're crazy. And now there's this back and forth argument. It's actually important to recognize that climate change is natural. We've had climate change long before we had humans driving cars or burning coal. So let's talk about some of those natural drivers of climate change. It's often known that the Earth orbits the sun, but there's actually, it's less known that the shape of that orbit actually changes over time. It changes from more circular to more elliptical and back again. It takes about 100,000 years to complete just one of those cycles. And then there's other planetary cycles that also vary, but they vary over these long periods, tens of thousands of year periods. And yes, they're important to the climate. Yes, they do influence temperatures, but they do so very gradually. And they fail to explain the sharp increase in temperatures that we've been seeing over the last couple centuries, and more increasingly so over the last few decades. So let's talk about some more natural drivers of climate change. The greenhouse effect, how many people have heard of that? That's also a natural process. In fact, if we didn't have the greenhouse effect, we'd be sitting on a temperature that's about 0 degrees temperature on average. It'd be a very frigid, inhospitable place. So we're grateful for this natural process. By the way, you've all experienced the greenhouse effect very noticeably if you've gotten in your car on a cold day. Even if it's cold but the sun's shining, it might be 20, 30, 40 degrees hotter in your car. That's because that energy from the sun is passing right through the glass, heating up the interior, and as those things get warm, they also radiate energy, but they do so at a different wavelength, and the glass actually, it can't get back out of the glass that wavelength. So you get a consequent increase in temperatures. That's what happens in your car on a sunny day. So what happens in a greenhouse, and that's also what happens here on planet Earth, but of course instead of the glass around the greenhouse, we've got an atmosphere. More specifically, we've got certain gases in the atmosphere called greenhouse gases that are really effective at trapping that outgoing radiation. So again, this is an important process that's natural, and it's also something that we're grateful for. But as you've always heard, too much of a good thing is a bad thing. And that's really what the story of climate change is. It's the thickening of this greenhouse, the thickening of the glass, if you will, that is causing temperatures to go up even more. And of course, how are we thickening the so-called glass? It's by burning coal, oil, natural gas for a very long time, and also some farming practices, different things over the course of human history that have given rise to CO2, methane, and a lot of these greenhouse gases from the ground, moving them into the atmosphere. So we've effectively added more blankets to the bed, or thickened the glass of the greenhouse, if you will. So here's what carbon dioxide has been doing for the last century and a half or so. The first part of the graph at the right is what is direct measurements of carbon dioxide measured by a scientist by the name of Charles David Keeling. Now, he was measuring carbon dioxide as part of his postdoctoral work when he was probably about my age. He ultimately earned himself a Nobel Prize for his postdoctoral work. I haven't quite got there yet. But he actually was measuring CO2 year after year after year, and he was finding that carbon dioxide was going up and up and up. He actually was, this would ultimately become his life's work, and this would be famously known as the Keeling Curve, showing CO2 rising in the atmosphere quickly over time. Now, this was essentially sounding the alarm that we had an impending climate crisis, given what we knew about carbon dioxide and its heat-trapping nature. Now, of course, here we are decades later, and we still have yet to do a whole lot about climate change. But the message starts a long time ago, CO2 rising up and up and up. But we find, using our ice core data and going further back in time, that CO2 actually started increasing long before Dr. Keeling started measuring it, but actually dating back to the mid-1800s, not surprisingly coinciding with the Industrial Revolution, when we were tapping into the earth, digging more coal, oil, natural gas to power our cars, to power our, produce electricity, and so on and so forth. So the explanation as to why CO2 has been rising is no mystery to science. It's very evident. Another misconception is we don't know what prehistoric CO2 and temperature was like. In fact, we actually have a lot of data, good data, that shows what both temperature and CO2 did a long time ago. Part of this is from drilling into deep underneath these old ancient glaciers, where there's actually little bubbles of trapped gas that are essentially showing us what the atmosphere was like hundreds of thousands of years ago. Now, this is looking at carbon dioxide in blue and temperature in red, going back 400,000 years. And by the way, I promise not too many graphs in this presentation, so don't start walking out yet. But this is an important graph. So what you're seeing, first off, climate change is natural, right? I mean, you're seeing temperatures go up and down for hundreds of thousands of years, and we weren't around to burn coal and oil. Actually, about this kind of matches well with those cycles, planetary cycles I talked about, which actually do fluctuate on tens of thousands and even hundreds of year cycles. So we do have natural drivers for climate change, as I mentioned. Another thing to notice is that temperature and CO2 go hand in hand. When one goes up, the other goes up. When one goes down, the other goes down. So these two things are very tightly coupled over recent geological history. Now, another important thing to note, I don't know if you can see the numbers, but it's about every 100,000 years or so you see one of these temperature carbon dioxide maximums. And we've got three maximums that we can see here. And at the very right, what you're looking at is carbon dioxide at 1950. And if you kind of look at this graph, you see, okay, well, in 1950, it looks comparable to those prior maximums. So around 1950, we're at one of these 100,000-year maximums. It's what's happened since 1950 that has myself and Athena on the road for climate action, and many scientists and nations and people all over the globe very concerned about climate change. And that's where carbon dioxide is now. From 310 parts per million in 1950 to 412 parts per million as of this week. So in just a 70-year period, we've gone way off the charts, even by geological history. 50% higher than these prior maximums, actually. And again, that's just in a 70-year period since 1950. Now, it doesn't take a statistician to see this graph and recognize that we've got a serious anomaly here. And if you know a bit about carbon dioxide and what it does in the atmosphere, you're very concerned about temperature. So the question is, where is this red line going to go? Where does temperature go as carbon dioxide just jumps off the chart like that? Well, we're starting to see some indicators of that right now. And by the way, I think that the lights, when it was semi-dimmed, I think that's fine. I think it doesn't need to be totally off, just in case for the camera purposes.
If we dim this side, we can't see this.
Sure.
I don't know how to dim that much.
Okay. Okay. So we're starting to see temperatures go up and up and up. Decade after decade, temperatures have been breaking new records. And in fact, as of this present last couple decades, we've got more heat records. In fact, 17 of the 18 hottest years on record fall just in the last 2 decades. So that's what we're talking about with temperature. And that's, again, where we're concerned as we see not just temperature go up, but a lot of the variety of climate impacts to follow. And I'll talk about that moving forward. Our journey on the road started out west. As I mentioned, I'm from Orange County, California. Or if I didn't mention that, that's where I'm from, born and raised. And we started out there. We headed up first through Nevada, ultimately into Utah. The story of climate change in much of the western states, California to Nevada, Arizona, is really one of increasing temperatures. And I'm sure all of you are observing increasing heat waves. Maybe this fall is hotter than it previously used to be or that you remember growing up. Certainly the case where I'm from, and when I visited Nevada, we saw Reno set the highest July heat record it's ever seen. People in Nevada are having their chickens die. I had one person tell me that she now knows what temperature a chicken dies at, and it's 117 degrees. So people all have their own little stories, different places you go. And it's not just the sort of ugly feeling of being really hot. Of course, these temperatures play into really important events that we're seeing break out all around the country. Fires. In fact, I think there's 12 going on right now in the state of California. We're talking about more, in fact, if you read the recent National Climate Assessment, they're talking about a future where it's not just droughts that are 7 or 8 years, but it talks about future mega droughts, the potential for mega droughts, decadal or multi-decadal drought events as we go into a sort of warmer phase in this planet. And the incidence of wildfires is extremely concerning. We're seeing not only places dry up, but we're seeing landscapes torch. And of course, if you're from California, you know that California is already a fire-prone state. It's already a drought-prone state. But again, we're talking about potential mega droughts moving forward. And with wildfires, we're seeing fires that are not just wild anymore, but burning through entire towns, as we saw in Paradise. I was visiting Redding, California, back in May, and audience members at my talk there had actually lost their homes in that fire. So we're seeing what seems to be a shift in just the way fires are burning across the state. And this is not just hearsay, it's not just concern from the media or news, it's actually in the data as well. And we could look at here, this is cumulative fire area, forest area burned in the United States. And if you look back from 1985, you see that the area burned has gone up. And each passing 5-year period, it just goes up and up and up. More area getting burned. If you compare this to, well, in fact, let me pause on that. I just want to say that scientists have looked at the increase in fires, and there's a variety of different variables that go into whether or not a fire burns, right? There's population, there's land, telephone wires across the state. A lot of things go into wildfire, taking place or prevalence. So scientists have looked very closely at this to try to disentangle the extent to which this is being contributed by increases in temperatures. And what they find is about half of today's fires could have been avoided had we not gone up in temperatures over the last several decades. And it's pretty intuitive as to how higher temperatures, higher annual temperatures could lead to wildfires. We're getting snow melting earlier in the season, creeks drying up quicker in the summer. We're getting vegetation, of course, being very dry. And then by fall, it's just a lot easier for a massive wildfire to start. And we are seeing Thomas Fire, biggest fire ever in the state's history, which beat the prior record a year before, the Tubbs Fire, the most destructive fire. If you look at California, of the 20 largest and most destructive wildfires in the state's history, about 15 of those have occurred in just the last 20 years. We can take a look at just the West. This graph I just showed you was the whole country. But if we look at the West, we're seeing 4 times more major wildfires today than 40 years ago. We're seeing 6 times the area burned compared to 40 years ago. And we're seeing the fire season grow by 70 days, about 71 days or so. The measure of when the first wildfire starts to when the last fire starts in the season. That's increased dramatically over the last few decades. Anybody heard of the bark beetle? Yeah, a few of you? So the bark beetle, and this is not drawn to scale, so don't worry. Some people don't want to go into a forest after I show this slide. The bark beetle is only about the size of a grain of rice, a very small beetle, but not harmless. In fact, it's very destructive to forests, about 30 different species or so, and it's a native bug to the country. But a few of these species actually will bore into the bark of a tree, and they'll actually cause the tree to die. Now, how does this fit in with climate change? The beetle's always been around. What used to happen, though, is this beetle used to bore into the bark and lay its larvae. But in the wintertime, especially in these high-altitude regions up in the Rockies, upper Utah, the beetle's larvae would basically get frozen out in the winter. Temperatures would just get too cold and it would die. So in the springtime, only so many of them would emerge as adult beetles and ultimately harm trees. And that was kind of a cycle that would repeat itself every year. However, since about the 1980s, temperatures haven't been cold enough in these high elevation areas to kill off these larvae. So come spring, you're getting masses and masses of bark beetles emerging and basically going to work on all these trees. And consequently, bark beetle levels have reached epidemic proportions. This is only exacerbated when you look at recent drought events, which have made trees a little bit weaker. They produce less sap. So we've got really a real problem across the country as it relates to forests. About 20% of Colorado's forest land is actually dead right now or dying as a result of the bark beetle, again, reaching epidemic levels. What you're seeing here, if you can see this picture, is a cluster of about 10 or 12 dead, I think these were ponderosa pines, up in Cedar Breaks National Monument, Utah, around 12,000 feet altitude. Now, this is what you see when you hike around that area. It's sad to see these clusters of dead trees, but this really didn't even prepare us for what we saw when we got to the top of the ridge, which was this entire hillside, if you can see that, is basically white. I mean, this is not a deciduous forest in the wintertime. This is an evergreen forest in the summertime, and it's completely devoid of greenery. It's a dead forest. And if we kind of go back a few slides, this ties right back into the wildfire issue that we just talked about. I mean, this is perfect foundation for a massive wildfire to break out. And one of my important topics that I study is air pollution. And you can see quite readily how this would fit into the story of air pollution. In fact, among elderly, there's about a 6% increase in hospital admissions when you have one of these major wildfire events, just because of the massive amount of smoke in the air. How about CO2 being good for agriculture? This is something that, anybody heard this before? So this is a common misconception as well. There's, first thing to mention is, you know, it's intuitive that carbon dioxide might be good for plants because we breathe oxygen, plants breathe carbon dioxide. So if we add more CO2 to the air, it's got to be good for plants. And to some extent, plants do benefit from more CO2. But importantly, there's a saturation point. You know, when we get above a certain amount of CO2, we can't just double the amount of carbon dioxide in this room and expect these plants to be double the size in a year. That's just not the way it works. There's a saturation point. Plants also depend on other important nutrients such as nitrogen, and it's actually nitrogen that tends to be the main limiting factor for growth, especially as you increase carbon dioxide. But importantly, putting that aside, there's just so many other things that carbon dioxide does other than impact plants. And as we're talking about wildfires, temperature, changes in precipitation, that we can't just simply isolate CO2 and plants and say, oh, well, it must be a good thing. As I'll talk about in the next couple slides, farmers are not telling you that carbon dioxide is doing them any good or that this increase over decades has been good for them. There's a lot of climatic events which are making things very destructive and harmful for agriculture across the country. And in fact, well, let's see. Okay, so we visited South Dakota, Iowa, Minnesota, different states that are really real breadbaskets for the country, and asked farmers, to what extent are you experiencing climate change? Are you experiencing climate change, seeing changes in weather patterns? And keep in mind, these are, of course, much like people perhaps in this audience who have been farmers or working the land for generations, so very in touch with weather patterns. And the answer we got from these farmers we spoke with was a resounding yes, we're being impacted pretty dramatically from what appears to be changes in climate. And the area out here, unlike a lot of California farming, is actually not irrigated. So if you drive up and down the Central Valley, you see those massive sprinklers that are irrigating the crops. Up there, it's not the case. They actually rely on regular rain patterns and precipitation to essentially water their crops. Well, the farmer that I spoke with here at this farm in South Dakota said that they're not necessarily seeing changes in annual precipitation, but what they are seeing is changes in how that precipitation and when that precipitation is being distributed. And they're seeing now sometimes 3 weeks with not a drop of rain. And then suddenly it'll just be a torrential downpour for a day or two. And I asked what one of these torrential downpours looks like, because intuitively it might seem like, well, a lot of rain is good for crops. But no, they're seeing actually, sorry, I should also mention, let me go here. Torrential downpours are not good for crops. I asked him what one of these events looked like. He said they got, this was Minnesota now, 17 inches of rain in a 24-hour period. Imagine that. I mean, we get 2 or 3 inches in California, and you know we're sort of heading for the caves. This is 17 inches of rain in a single day. I asked him to paint a picture for me in my mind what that could have looked like, and he said it looked like trees flowing down the highway, and it looked like hillsides collapsing during these conditions. If you can imagine just the massive amount of soil erosion that takes place, you know, during that event. He said his neighbor had a potato crop, and all the potatoes were uncovered, contaminated, and he lost the whole crop. And he had a contract with Whole Foods he wasn't able to fulfill. And these are the types of stories you hear as you talk to farmers across the country. It's a story of struggle and difficulty because, again, climate, you know, maybe it rains here or it snows or we get a cold snap, we go into our homes and it's okay, but their livelihood is dependent on weather. And the same thing, we talked to farmers in the Northeast, a little bit different stories, but they're seeing these dramatic cold snaps where even the peaches and apples, which are cold-adapted species, their buds will actually get so cold that they'll actually basically die in the winter conditions because they've been getting some record cold events. But then in the spring, the ones that make it will flower, and then suddenly you'll get what they call a cold snap, and it's a late spring freeze that just descends on that country and all the flowers. And I experienced this. I lived in Massachusetts for 6 years, and I would always look forward to the tulips blooming and everything really coming to life. And the last couple of years I was there, I noticed that we suddenly would get one of these real cold snap periods that were not very common, and all the flowers were under a foot of snow. And when that snow would melt in the coming week or two, all the flowers were dead, and spring just kind of ended, and it was a little bit sad. But for me, it was a visual thing. For these farmers, of course, you lose your flowers on your apple tree, and that's a big problem. So farmers have actually been having zero production in some of these farms across the Northeast. We also traveled through the south and areas along the coastline, which are being impacted by and very concerned about sea level rise. I actually took this photo. I'm not sure if you can see, but this is actually a community, a neighborhood that's about 6 inches under seawater. Okay, this is ocean water that we saw, and I talked to one of the people out there. There's actually a news crew showing this. By the way, this is under a king tide condition, so this is really every few months you get a super high tide, and those super high tides are getting even higher and higher, and there's basically ocean just coming up into people's front yards now. And there's about 3 months ago, prior to this, we were told by one of the people that this is actually a pretty mild king tide. The last one was about knee high with water. And these are communities that are right at sea level, so it doesn't take much water to flood their homes and things like that. This is just one more sort of indicator that climate change is not a next generation or a future problem. It's a very much a here problem and a now problem and a this generation problem, whether it's sea level rise along the coastlines or it's the bark beetle and forest devastation or coral reefs or something like that. And I actually, where I live is pretty close to the coastline, and there's real big homes right on the water, and they have little levees that have always been there. But if you go there during a king tide event, you'll actually see these multi-million-dollar houses with 6 inches of seawater, 6 inches away from seawater, just breaching over and just totally filling up and inundating the whole area. I mean, it's pretty wild to see this, and certainly this was not the case decades ago, but they're in fact requiring homes to be built on 17 inches higher land now as a result of this. So, famous calculation, if Greenland ice sheet were to melt, it would raise sea levels by, anybody know? By about 20 feet. Yeah, I saw you saying about 20 feet if Greenland were to melt. Now, that's not talking about the Antarctic. This is just, now this is not going to happen tomorrow or in a year or so, but Patagonia, Greenland, Antarctic, these are places that are melting at an increasing rate, and we should definitely be concerned as we're seeing these high rates of sea level rise. We're also seeing coral reefs. Anybody seen the movie or documentary Chasing Coral? It was on Netflix for a while. A few of you. It might still be on there. It documents the 2016 marine heating event, which was a massive global warming event in the oceans. And it really destroyed lots of coral reefs around the world. About 30% of the Great Barrier Reef turned from this to this to this. And coral reefs don't regenerate overnight. They take about 20 years or so to regenerate. These warming events are starting to happen every 10 years or so in a lot of reefs around the country or world. And this is not an issue just for snorkelers or tourists. It's an issue for the billion or so people who rely on fish for their main source of protein. Hurricanes, we traveled through the south, and hurricanes are one of those things that climate scientists have been telling us for quite some time we need to be concerned about, because hurricanes get their energy from surface waters. So when you have a warm surface water, or a warm surface ocean, you have a stronger hurricane. And the warmer the surface water, the stronger the hurricane. As we heat up the globe, there's a much higher likelihood that a Category 3 or 4 hurricane can turn into a Category 4 or 5 hurricane. And certainly what we've seen over the last few years with Houston going underwater, the most precipitation ever dumped from a storm in the history of, on record in the United States. In fact, it beat the prior record by about a foot of rain. Again, that was Hurricane Harvey in Houston about 2 years ago. Just a week later, Irma came, Category 5 hurricane, set the record for high sustained wind speed of a hurricane, and then just a week or two later, Hurricane Maria, same thing, a record breaker, but in this case, just destroying Puerto Rico, leaving many people dead and in bad condition. We actually saw a hurricane, sorry, let me back up. We saw the aftermath of a hurricane, Hurricane Michael. On our journey, we saw 2 record-breaking hurricanes along our route. Hurricane Florence up in North Carolina, and a week or 2 later, Hurricane Michael, which was the biggest hurricane on record to hit the Panhandle. A few miles per hour shy of being a Category 5 hurricane. And we passed through 3 days later. It still looked like a war zone. This was our car driving through there, trees down in the background. And you can see this was a storm that not only destroyed houses and man-made structures, but in fact cleared entire forests. If you can see this picture, this is a forest that's essentially been wiped out. There's nothing but tree trunks left here. And talking to some people in the area who had just lost their homes, people are very much concerned about, do we move back to an area like this? It seems like every year things are getting a little bit more risky. And, in fact, when you look at the last couple of years, you can never call any single storm or hurricane a climate hurricane or a climate storm, but we should be looking at patterns. And the last couple of years have shown us enough major storms to be concerned about, and this could very well be a glimpse into the future under a warmer climate where we have more Category 5 hurricanes. And in fact, there's a book by Bill McKibben that was published a few years ago called Earth. But Earth is spelt with 2 A's. And the reason that he spells Earth with 2 A's is to convey that we're quite literally moving, or quite potentially moving into a planet that's going to look so different climatically in the future that we shouldn't even spell Earth the same. And I think there's a lot of merit to that argument when we talk about hurricanes and wildfires and droughts. Everything just seems to be like it should have the preface mega before it. Mega hurricanes, mega droughts, mega wildfires. And this is something that I think that book drives home pretty well. So all of these things are pretty sad and depressing. But is it just the people in the South? Is it just the people living in the forests in the Rockies? Just the people along the coastline? No, it's not. And in fact, we all care about the economy, right? And the economy is tied very closely to climate change, and I don't think we talk about that enough. There's this notion that reducing carbon emissions is going to be too costly, but in fact, the most costly thing we could do is ignore climate change and let things move forward business as usual. So I want to show you just a graph looking at a list of what are called billion-dollar disasters. So this is just looking at natural disasters in the US. And every time there's a natural disaster, whether it's a hurricane, a flood, a wildfire, if it costs $1 billion to the US economy, it gets logged on a list that's on the public record. And this list goes back to 1980. So let's take a look at the number of billion-dollar disasters that have happened since 1980. Well, in the early 80s, we had 28 of these billion-dollar disasters. In the 90s, 52. Early 2000s, 59. What about this decade, which is not completely over? We've got over 111 of these billion-dollar disasters. As you can imagine, the economic cost of these disasters just go up astronomically from 170 billion in the 80s, 266 billion in the 90s, 500, and then ultimately this decade, which is not over yet, we're getting towards $1 trillion, $750 billion of damage. And that's not an updated figure because it takes several months for them to update the record with new disasters that have already happened since then. So the economic impacts of climate-related natural disasters have been going up dramatically. And this is just looking at that one component of climate change. There's still the public health cost of just burning coal and oil and gas from our cars that are bad for our respiratory system, cause asthma, lead to premature mortality, and things like that. So there's a whole lot of other things we could look at, and you'll see that sort of climate-related tab really go up. So that's something important to keep in mind next time you hear somebody say, well, addressing climate change is too expensive. In fact, ignoring climate change is more expensive, and the thing with ignoring it is it only gets worse and worse and worse over time. How about this notion that it's too late for the climate? It sounds like a lot of things are happening right now, and it's pretty scary. Is it even worth dedicating ourselves to try to do anything at this point? And the answer is absolutely, it's not too late for the climate. In fact, we have projections. If we just look at sea level rise, the projections for future sea level rise are still dramatically different. From a foot of sea level rise to 3, 4, or I've seen projections of up to 8 feet of sea level rise by 2100. Now that's a pretty wide range. And whether we go down the 1 foot of sea level rise or the 5 or 6 or more feet of sea level rise depends entirely on how we act today. Whether we get our acts together nationally, globally to really address this climate change problem like we've done with other problems such as the ozone depletion problem. That's going to determine which path we go down. So there's every reason to really still try to get a hold of this problem, most definitely. And this is just looking at sea level rise, but of course we can assume a similar kind of difference in trajectories for all kinds of natural disasters and impacts. I'm only one person. There's not much I can do. Also, a tragic misconception. We are all individuals, but just look at this audience. There's got to be 500 people in here. And that's not a small impact. I'm only one person, and I sat in my desk, working as just an everyday scientist, thinking I'm only one person, what can I do? And this last year I've done nothing but be on the road talking to climate change, communities about climate change, and I feel like that's been a really good use of my time. And it's not the greatest financial decision in the world, so I don't, but it makes me feel really happy that I'm doing something to address a really important problem. And I think that all of us can tap into something that they can do as an individual, and I don't think all of us can go on the road, but I think that there's something that you can do in your everyday lives to try to address this problem, and it's all about just trying to do that one thing, or a few things, whatever you can do. Raise awareness is one thing. I think this is one of the most underrated things that we can do to address climate change. That's got to be good, right? Because it's pretty easy for people to raise awareness. We don't have to go anywhere or spend much money. We just have to talk about climate change and talk about it with your friends, family, colleagues, coworkers. Use social media for this. We actually have a unique opportunity at our hands. 10, 20 years ago, if you wanted to share the news, you had to be a news reporter. You had to get a job at the LA Times or the New York Times and publish an article. Not the case anymore today. You can actually just publish existing papers on your Facebook page, which you've got, a couple hundred of you if you're, my parents' age, or a couple thousand of you if you're my niece's age. You got a lot of Facebook friends. So use your platforms to raise awareness about climate change and share that article that NASA published about the Arctic melting in the dead of winter. These are the kind of headlines that I think people need to increasingly start seeing, and unfortunately we're not seeing enough of it on the nighttime news. So use your own platforms to try to make that happen, whether it's Facebook, Instagram, or Twitter. And you can actually look at data, and this is not going to surprise anybody, this is my own data, but when you talk to college people or older people, you find that college kids actually tend to use Facebook as their main source of news. And this is, when you ask adults, or I shouldn't say adults, college kids are adults, but when you look at, my parents' generation or so, you find that the newspaper is their top source of news, but not the case among college students. So just another reminder that we have the potential to reach a really important group of people, college-age people with important news. Now, sadly, this issue has really become a political issue, right? It's been really politicized over the decades that we've ever heard of climate change. And I think that we can all play a part in trying to disentangle that and remove it from politics. It's still a sort of contentious topic, an awkward hush-hush topic that we don't want to bring up at the dinner table. I think we've probably all felt that before. You don't want to talk about climate change in unfamiliar company. But really, we don't solve problems that we don't talk about. And we just need to talk about this issue. I always say that the earth is not partisan. And, decades ago, it actually wasn't even in politics. But today it is, and let's try to break past that. It's really up to all of us to kind of remove it from that awkward political arena and just talk about it for what it is. It's an issue of the environment, and I think we all care about the environment, right? I think one of the most important ways that we can successfully bridge people from all political backgrounds and other backgrounds together in support of trying to do something about climate change is really just connecting the dots as it relates to this issue. And I'll explain what I mean. We have this issue, for instance, of the refugee crisis, which has really gotten a lot of spotlight in public discourse. Well, there's now actually more environmental refugees today than there are political refugees. Climate change is very much a refugee problem. 30 million people displaced from their homes every year from a natural disaster, wildfire, a drought, famine, and again, more than your political reasons. So if you're concerned about the refugee crisis, then you're concerned about climate change. If you're concerned about the economy, well, we already talked to some length about that, then you're also concerned about climate change. War and conflict, we all care about national security. If you read Pentagon papers, Pentagon reports, you find that there's very good reason that they talk about climate change as a really important national security threat. We don't see reduced conflict and more peace as we have major agricultural disruptions, as we have massive droughts, as people are migrating across borders at a higher rate. No, that all actually breeds more conflict, more global tension, and it reduces our national security. So it's actually a really important national security issue, this issue of climate change. Another way we can start reframing the climate conversation. Jobs, poverty, also important. Let's talk about jobs. Jobs are actually one of the areas where I get to talk very positively about climate change because we actually have a real big opportunity on our hands to put a lot of people to work to address climate change. There's actually, in 2016, there were 70,000 jobs added to the US economy through wind, 25,000 jobs added from solar. 20% of the 6.5 million construction workers were actually working on energy efficiency projects. So if we choose to continue pursuing a green infrastructure, renewable energy, solar, wind, all that good stuff, we have a real opportunity at our hands to continue to put people to work. I mentioned 70,000 people put to work for wind in 1 year. You know how many people the coal sector employs, period? It's about 70,000 people, the entire coal sector. And that's just when you compare it to wind, that was just 1 year of wind is 70,000. So again, a real bright future as it relates to renewable energy. And of course, the people who do work in coal sectors and other industries, we don't need to leave them behind. No, we need to retrain these people and bring them into the new economy as we move forward. This graph is going to be very difficult for people to understand, so I'm just going to kind of describe what you're seeing here. This is actually survey data that I collected from my time on the road, and I asked people the question, what's your top climate-related concern? And in the black is what people ranked as their number one concern. So all of these things that are these tall bars on the left, the most prominent one for people's top concern was future generations. And I think that's interesting because I think it informs climate communicators such as myself and others that we've got to do a much better job at telling people that this is not a future generation problem. This is a today problem and it's a now problem. And we need to really start thinking about it in that way. But I think this graph is interesting for another reason. Not only all the things that are highlighted on the left, these big bars, but actually what's totally missing on the right, these categories that people just didn't rank. Well, that actually, if you can't read it, or maybe you can, it's the economy, it's property value, it's national security, it's infectious disease. These are things that people really care about in the United States. I mean, the economy, national security. Why are they not popping up at all under this questionnaire? This gets back to the idea of connecting the dots, and I think that a lot of people still aren't connecting the dots between these really important issues and climate change. But the moment we can connect the dots for ourselves and those around us, that these are all interrelated issues that fall under the umbrella of climate change, the moment I think we can get a lot more action and mobilization for people to want to take action on this issue of climate change because it affects us all and it affects all those issues we really care about. So I advocate for people, this is part where we get to sort of climate solutions. What can I do? I'm sure a lot of people are thinking, what can I do to address this issue? At the top of this, I kind of identify 3 pillars, and the most important pillar I put at the top is actually going out and voting. And I don't go out telling people to vote for Republicans or Democrats. I just advocate for people to vote for the climate and vote for the environment. Vote for our Earth, because when we vote in favor of our Earth, we do in fact vote for our society and everybody who lives on this planet. There are bills right now in Congress. One of them is called H.R. 763. This is a bill that actually proposes to put a price on carbon emissions. Just like we all, you have to pay a price to dispose of hazardous waste at the landfill. For generations, we've actually been treating the atmosphere like an open, free waste site for carbon dioxide and other greenhouse gases. And if we want to really address this issue, economists have been saying for a long time that we need to put a price on carbon emissions so these companies have to pay in order to pollute the atmosphere. And that'll also provide a disincentive for that pollution to take take place moving forward. Now, HR 763 is just one example of a carbon pricing bill. I think at this point there's got to be about 5 or 6 or so in Congress right now. So I just encourage people to take a look at the different bills that are on the table today and learn as much as you can about them and really try to support initiatives that are going to reduce greenhouse gas emissions and in turn benefit our society. Develop relationships with your politicians, whether they're Republican or Democrats. These are my congressmen of the same district. This was the former congressman. This is our current congressman. They both own copies of my book. I don't know if any of them have ever read it, but they at least have it. But I just encourage you to, write letters, make phone calls, meet your congressperson. These are people, and they're oftentimes in your districts at their offices, and they're willing to meet with people all the time and hear your thoughts and concerns. Give presentations. You don't have to be a trained speaker to get out there and give talks on climate change. If you're in college, there's some junior highs or high schools that would love to have a college person come and talk to them, especially if you're a science major, about climate change. But really, anybody can get involved in public speaking and talking to your local, maybe it's a church group or a Rotary Club or what have you. And just in closing, I have a website where I encourage everybody to check out and tune into this climate journey that I'm on, and also to just learn updates as it relates to climate change, the environment. The website is roadforclimateaction.com, and you can also get there by shahirmasri.com, which is my name. On the website, I oftentimes publishing videos. So we've been on the road for a large part of this last year, and a big part of what we wanted to do was take climate change away from the space of just graphs and parts per million and these sort of abstract figures that don't really stir us emotionally, and actually show what's happening to people around the country as it relates to changes in weather and climate. And we asked, we interviewed a lot of people along the way, and we're bringing those videos and those interviews to the website every couple of weeks. If you sign up for my newsletter, it's in the back left part of the room, just over there. I'll be happy to put you on my newsletter. It only goes out every 2 weeks, so I don't overburden you. I couldn't publish it any faster than that if I tried. It's already very time-consuming. But I encourage you to subscribe to the newsletter, tap into the website, send me an email. Let's keep this climate conversation going. I also have social media and things like that. This whole project, this whole effort was donation-based. So I don't have any big donors from anywhere. It's all just people at talks that have funded, given donations, or schools that have asked us to come talk. And I think that's something that's also exciting for anybody who has a big idea and you want to go out there and do it. You don't necessarily have to have the funding in your pocket. If you're passionate and people want to see this happen, you can actually go to a page like GoFundMe and start a grassroots movement and try to get action on your passion. And just continue to learn and continue to share. I think this is so incredibly important. Again, my book, Beyond Debate, is in the back of the room. And again, it's 50 chapters, 50 misconceptions explained in 50 short chapters. Over 170 references, really designed as a resource for climate activists and advocates, but also just for people trying to understand the issue that aren't quite familiar with it at this point. You don't have to read any of the chapters in order, which is kind of what I thought would be most useful. You can kind of flip through any topic and start reading there. So it's not an overwhelming book to pick up. And that's available right there in the back left of the room. You can come pick it up after your talk. Be happy to sign a copy for you. And today there's no tax, no shipping, so come meet me after the booth. And I think we have time now for a Q&A, but before I say that, I want to mention that I have an Instagram, so if you want to follow this journey through Instagram, I know at least a third of the audience here, the college audience, has Instagram. Feel free to follow me. It's at dr.shahirmasri, and you'll probably see a story on there from tonight. And that's a place where I'm oftentimes giving away free books and showing pictures of different things and interviews with people around the country relating to climate change. So thank you all very much. It's really been a privilege to be up here today. My first time to Modesto, and hopefully not my last. This is great, so thank you.